graphing quadratic functions. So I'm just going to give you a heads up. This video might be a little lengthy because we're going to work out two quadratic functions to find those four key pieces of information in order to graph them, and then we're going to do a quick sketch of each one as well. So just kind of as a refresher, our axis of symmetry, the equation is negative b over 2a is going to equal that x, and we said your axis of symmetry is that imaginary vertical line where your parabola is going to form its mirrored image over, okay? And your y-intercept is always going to be your c value, which we'll talk about in a second. So when you're using your standard form for the quadratic function, that's how we're going to solve these. I'm going to write over here negative b over 2a so that we don't forget when we end up working out all of this information. Okay, so the first thing you want to find is your y-intercept. We already know what our y-intercept is because it's the value of c. So your y-intercept in this case is going to be when x is 0, your y is a negative 7. So you didn't necessarily have to do any math for that one. In order to find my axis of symmetry, our equation is negative b over 2a. So when I plug in my information, my b is a 9, so negative b would give me negative 9 over 2 times my a value. My a was a negative 3. So when I plug this in, I get negative 9 over negative 6, which reduces to 3/2, or 1 1/2. So I'm going to put positive 1 1/2 for my x. So when x is positive 1 1/2, that's where I'm going to have my vertical line, which we'll kind of talk about in a second. For the next piece is my vertex. So the vertex is your minimum or your maximum. Remember, it's an ordered pair. Since my a, this leading coefficient, is a negative, I know that my parabola is going to open down. It's going to be upside down, which means I'm going to end up with a maximum for this problem. For your vertex, your axis of symmetry, we said, was the x value. So I'm going to put 1 1/2 here, but I still need to solve for that y value. In order to solve for the y value, you're simply going to plug the x into your equation for x and solve this whole function for y. So I would suggest keeping your fraction as improper because it's going to be easier to square that value. So when I plug it into my equation, this is when you're going to have to do the most work, is finding this vertex. So when I plug it into my equation, I get negative 3 times 3/2 squared plus 9 times 3/2 minus 7 at the end. When you're squaring a fraction, you have to square both pieces. So I have my negative 3 out in front, and I get 9 over 4. Plus, if I write whole numbers as fractions over 1, I can do numerator times numerator, denominator times denominator. So I get 27 over 2, and I still have my minus 7. If I keep solving, again, change this as a 1, so I get negative 27 over 4 plus 27 over 2 minus 7. Now, if you want to keep them as fractions, remember you have to find a common denominator. So in this case, my common denominator is going to be a 4. So if I write this whole thing over 4, I don't have to change this first fraction, so it stays a negative 27 on top. If I need to multiply this by 2, I'd have to multiply the top by 2 as well, so I get a positive 54, and I can write it over 1, so I'd have to multiply both pieces by 4, so I get a negative 28. When I go to solve this, negative 27 plus 54 is going to give me a positive 27 minus 28 all over 4, which means I get negative 1/4. So my y value of my vertex is negative 1/4. In order to find the zeros, so the last step before we do a quick graph, in order to find the zeros, you would do factoring, how we did before. So since we have a leading coefficient that is not 1, we're going to find two numbers that multiply to give me a positive 21, that add to give me a positive 9. So I want two numbers that multiply to give me a 21 because 3 times 7 gave me that 21. So when I write out my multiples, I get 1 and 21, and I get 3 and 7. Now, when I add these together, 21 and 1 is going to give me 22, 3 and 7 is going to give me 10. Since none of these can multiply to give you 21 and add to give you 9, you're going to have no solution. So you're not going to have any zeros in this graph. So now that we have our 4 key pieces of information, I can draw my quadratic function. If I draw a quick little coordinate plane here, even though it's not straight, my y-intercept is at negative 7. So I know that if we go to negative 7, 1, 2, 3, 4, 5, 6, let's say this is negative 7, I'm going to have a point right there. I also know that my axis of symmetry is at positive 1.5 on my x, so 1, 2, so halfway is going to be there. I know that my vertex is at 1 1/2, so at my x value of my axis of symmetry, and at negative 1/4. So it's going to be below my x-axis, and I know I'm not going to have any zeros because this is my maximum point. So I can connect these two. But now I have to do my mirrored on the other side. So since this went over 1.5 spaces, I need to do the same thing. If this is 1.5 spaces away, it needs to be 1.5 spaces on the other side. So 1.5. When I connect those two, this ordered pair is going to be at 3, negative 7. This is at 0, negative 7. And this ordered pair is my 1 1/2, negative 1/4. Okay, so we're going to do one more that's similar. If you need to pause and go back over that one, or just take a second before we start on this next one. So again, we're going to find those 4 key pieces of information. In this case, our graph will have zeros, so there'll be a little extra work at the end of this one. But we're starting with our y-intercept. Remember, your y-intercept is always that c value. So in this case, my y-intercept, when x is 0, my y is going to give me 6. That's what I know about my y-intercept. My axis of symmetry. We said the equation for axis of symmetry was negative b over 2a. So if I have negative b over 2a, a negative b, so I would have negative negative 5, over 2, my a. If there's not a number in front, it's understood to be a 1. Negative times a negative makes it a positive. 2 times 1 is 2. So I'm going to have 5 halves, or 2 and 1 half. So my axis of symmetry is going to be at 2 and 1 half. Remember, we said when you're solving for your vertex, the x value of your vertex is going to be the x of your axis of symmetry. So 2 and 1 half. And now we have to calculate our y. Since my leading coefficient a is a positive, that means I'm going to have a minimum in this case because my parabola is going to open up. So I'm going to have a lowest point on my parabola. So when I go to solve for my vertex, we said you're plugging in the x value into your x of your equation to solve for y. So again, use your improper fraction because it's going to be easier to square that value. Unless you're using a calculator, then you can use decimals. So since I'm not, I'm going to have 5 halves squared minus 5 times 5 halves, and then plus 6. So when I go to solve this, everything gets squared, so this is going to give me 25 over 4 minus 25 over 2 plus 6 over 1. Again, my common denominator is going to be a 4. Nothing changes to the first one. It's going to be a minus 50 because I'd have to multiply both pieces by 2. And it's going to be a plus 24. So when I do some math, I get negative 25 plus 24 over 4, which is going to give me a negative 1/4. So my y value is negative 1/4 for my vertex. So now finding my zeros, we said to find the zeros, this is when you do your factoring. So when I factor this, if I had x squared minus 5x plus 6, we said you need two numbers that are going to multiply to give you a 6, and when you add, they're going to give you a negative 5. That's because if I had a 1 here, 1 times 6 would give me 6. In the previous problem, we had another number, so it would have been that number times your c to give you that value. So start by writing down all your multiples of 6. So I have 1 times 6, 2 times 3. So we need it to be a positive, and we know that the rules when multiplying, if I have two positives that I'm multiplying, it gives me a positive, or if I have two negatives that I'm multiplying, it's still going to give me a positive. So because I want this to be a negative 5, we're multiplying them, but they have to be the same sign. So if I did negative 1 and negative 6, that's going to give me a negative 7. If I did positives, it would give me a positive 7. So it can't be that one. If I had two negatives here, negative 2 and negative 3, give me that negative 5. So this is the set of ordered pairs that I'm going to use. Remember, once you find those 2 points, you're going to plug it in or replace it for that middle term. So when I rewrite, I get x squared minus 2x minus 3x plus 6. And now you can do your grouping. So when I group these two, what I have in common is a single x. So I'm left with x minus 2. When I group those last two, I can pull out a negative 3. So I'm left with x minus 2. So when I rewrite, I get x minus 2 and x minus 3. So in order to find the value of your zeros, you need to know when are both of these going to equal 0 on their own. So if I rewrite this, x minus 2 is going to equal 0, and x minus 3 is going to equal 0. Now you're going to solve for your x. So if I want the x, I have to get rid of the 2, so I'm going to add 2 to both sides. If I add 3 to both sides for the second one, so the 2 points where your parabola is going to touch your x-axis are going to be at positive 2 and positive 3. So now we're going to use all this information to graph like we did in the previous example. So if I draw my coordinate plane, I have a y-intercept of positive 6. So 1, 2, 3, 4, 5, 6. So here's my y-intercept. This is my 0, 6. I have an axis of symmetry at 2.5. So if I draw my imaginary vertical line, it's not so vertical, at 2.5, I have a minimum where it has 2.5 and negative 1/4, so it's going to be right here. And I also know that it's going to cross at positive 2 on my x and at positive 3 on my x. The only other point that I need to do is the mirrored of this 6. So if it was over 2.5 from that imaginary line, it still needs to go over 2.5 on the other side. So 1, this would be a half, 1, 2, up to my 6. So this is going to give me 1, 2, 3, 4, 5, 6 as my ordered pair. And then all I'm doing is going to connect my point. You really only need 3 points in order to form your parabola. You need your y-intercept, you need your vertex, and you need that mirrored image of your y-intercept. You don't necessarily need the zeros. It just might ask you to solve for those zeros, of which you would do your factoring format.